Introduction. Artificial intelligence, AI, is a branch of computer science that aims to create systems capable of performing tasks that require human intelligence. These tasks include problem-solving, learning, planning, understanding natural language, recognizing patterns, and making decisions. AI has evolved significantly over the past few decades and has become an integral part of various industries, transforming the way we live and work. Historical background. The concept of AI can be traced back to ancient history, with myths and stories about artificial beings endowed with intelligence. However, the formal inception of AI as a field of study began in the mid-20th century. Early milestones. 1943, Warren McCulloch and Walter Pitts developed the first mathematical model for neural networks, laying the groundwork for neural computation. 1950, Alan Turing introduced the Turing test, a criterion for determining a machine's ability to exhibit intelligent behavior equivalent to or indistinguishable from that of a human. 1956, the term artificial intelligence was coined during the Dartmouth Conference, organized by John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon. This event is often considered the birth of AI as a research discipline. Evolution of AI. 1960s to 1970s, AI research focused on symbolic methods and expert systems. The development of algorithms such as the Dijkstra's algorithm for shortest paths and the introduction of the Lisp programming language were significant. 1980s, the advent of machine learning, a subfield of AI, marked a shift towards statistical and probabilistic methods. The backpropagation algorithm for training neural networks was popularized. 1990s, AI saw practical applications with advancements in computational power and data availability. Notable achievements include IBM's Deep Blue defeating world chess champion Garry Kasparov in 1997. Types of artificial intelligence. AI can be categorized based on its capabilities and functionalities. Based on capabilities. Narrow AI, weak AI, AI systems designed for specific tasks, such as virtual assistants, e.g., Siri, Alexa, recommendation systems, and image recognition. These systems do not possess general intelligence and cannot perform tasks outside their designated domain. General AI, strong AI, hypothetical AI systems with generalized cognitive abilities, similar to human intelligence. These systems can understand, learn, and apply knowledge across various domains. General AI remains a theoretical concept and has not been realized yet. Superintelligent AI, an advanced form of AI that surpasses human intelligence in all aspects. Superintelligent AI could potentially solve complex global challenges, but also poses significant ethical and existential risks. Based on functionalities. Reactive machines, these AI systems can perform specific tasks based on pre-programmed rules, but do not have memory or learning capabilities. IBM's Deep Blue is an example of a reactive machine. Limited memory, AI systems that can learn from historical data to make decisions. Most current AI applications, such as self-driving cars and recommendation systems, fall into this category. Theory of mind, AI systems that can understand and interpret human emotions, beliefs, and intentions. This level of AI is still in the research stage. Self-aware AI, theoretical AI systems that possess self-awareness and consciousness. Achieving self-aware AI remains a significant challenge and is a topic of philosophical and ethical debate. Neural networks and deep learning. Neural networks are computational models inspired by the human brain's structure and function. They consist of interconnected layers of nodes, neurons, that process input data and generate output. Deep learning, a subset of machine learning, involves neural networks with multiple hidden layers, deep neural networks, that can model complex patterns and representations. Natural language processing, NLP. NLP enables AI systems to understand, interpret, and generate human language. Techniques in NLP include tokenization, part-of-speech tagging, named entity recognition, and sentiment analysis. Advanced NLP models, such as transformers, e.g., BERT, GPT, have significantly improved the ability of AI systems to handle language-related tasks. Neural networks and deep learning. Neural networks are computational models inspired by the human brain's structure and function. They consist of interconnected layers of nodes, neurons, that process input data and generate output. Deep learning, a subset of machine learning, involves neural networks with multiple hidden layers, deep neural networks, that can model complex patterns and representations. Natural language processing, NLP. NLP enables AI systems to understand, interpret, and generate human language. Techniques in NLP include tokenization, part-of-speech tagging, named entity recognition, and sentiment analysis. Advanced NLP models, such as transformers, e.g., BERT, GPT, have significantly improved the ability of AI systems to handle language-related tasks. Computer vision. Computer vision focuses on enabling AI systems to interpret and understand visual information from the world. Techniques in computer vision include image classification, object detection, and image segmentation. Convolutional neural networks, CNNs, are commonly used in computer vision applications. Robotics. Robotics involves the design and development of robots that can perform tasks autonomously or semi-autonomously. AI techniques, such as reinforcement learning and computer vision, are integrated into robotic systems to enhance their capabilities in navigation, manipulation, and interaction with the environment. Applications of AI. AI has a wide range of applications across various industries, improving efficiency, accuracy, and decision-making. Healthcare. Medical imaging. AI algorithms can analyze medical images, e.g., X-rays, MRIs, to detect diseases and abnormalities with high accuracy. Drug discovery. AI accelerates the drug discovery process by predicting potential drug candidates and their interactions with biological targets. Personalized medicine. AI enables the development of personalized treatment plans based on individual patient data, improving outcomes and reducing side effects. Finance. Fraud detection. AI systems can analyze transaction patterns to identify and prevent fraudulent activities in real time. Algorithmic trading. AI-driven algorithms can analyze market data and execute trades at high speeds, optimizing investment strategies. Credit scoring. AI models assess creditworthiness by analyzing various data sources, enabling more accurate and fair lending decisions. Manufacturing. Quality control. AI systems inspect products for defects and inconsistencies, ensuring high-quality standards. Predictive maintenance. AI predicts equipment failures and schedules maintenance, reducing downtime and operational costs. Supply chain optimization. AI enhances supply chain management by forecasting demand, optimizing logistics, and reducing waste.